This video is going to introduce you to R, which is a commonly used statistical software package that you can use as an alternative to SPSS. In fact, in industry, R is probably a little bit more common than SPSS, but it's more difficult to learn, and that's why we use SPSS here at IMC. So let me emphasize that you don't need to watch this video. You can stop it now if you want. You never have to go near R. However, if you're going to be a marketing analytics student, or if you want to work in analytics, having R is going to be a big benefit to you. So the first thing that you have to do is install it. So R is a free software package. It's open source. You can download it by clicking on this CRAN website. So I just did that, and this is what you end up getting. So you get to the Comprehensive R Archive Network. That's what CRAN stands for. And then you download whichever version you want. You install it, and that's it. Now, there's going to be an icon for R. I can't show that to you because it's off on my other screen. However, if you click it, this is what you will get. You'll get something that looks like this, the R console. Now, the first thing that you want to know how to do is how to quit. If you're using this R console, you can go up to File, Quit, or you can do it the old-fashioned way, which is Q parenthesis parenthesis, which means I want to quit. So, do I want to save my session? Yeah, we might as well. All right, so that is how you start and exit R. So again, I'm going to bring it back. I just clicked on the R icon, and this is what you get when you start. So notice that all you have is a cursor. You don't have a friendly menu the way you have in SPSS. Now, when you get more advanced, you don't want those menus. You find them kind of cumbersome and awkward, and you're very happy to have nothing but this little prompt. All right, I'm going to show you a second way that you can access R if you're on a Mac. And I'm going to be using this for my demonstrations today. You can go to a terminal window and just type R, and you get the same prompt. I'm going to be doing the demos today using a terminal window rather than this. Either one will work. All right, so if you go back to the course packet, I have some fundamentals that you can read through on your own. So it's case sensitive, unlike SPSS. So all three of these things would be very different. Another thing that you want to know about is how do you get help? So you can get help on any function in R by typing question mark and the function name. So if you say question mark mean, you are going to get a help page that describes all the options and what happens with mean. So it gives you the details of how it does a trim mean and so forth. Okay. One other thing, if you ever want to, if you're not sure how to do something, so the question mark thing that I just did requires that you know the name of the function. But let's say I didn't know how to do a regression in R, or let's say independent sample t-test. Just Google it. So I would type R, I got to spell it right, D-E-P-E-N, better type sample t-test. And Google is really good at finding these. So you can click on this and you'll find out that there's actually a function called t-test for doing t-tests. And so just get in the habit of using Google to find help. So in other words, I just found out that the t-test function does t-tests, and here's, I can get additional help this way. Okay, that's how you get help. Okay, we've already talked about quit. You can use the up arrow to bring back your previous commands. So I just hit the up arrow. This will save you from having to type a lot of commands. You can edit them again. All right, so that's how you can edit previous commands. A few other routine things. If you want to put a comment in, you use the hash sign. This is more for programming, so it doesn't really concern us so much now. But if I say hash, this is a comment, you'll see R just ignores it. It's a comment. Okay, T and F are constants. Don't ever label a variable T or F because R will get very confused. NA is missing, so NA is just like the dot in SPSS, meaning missing value. Another difference between R and SPSS is that it has two equals. So equals is a logical equals, like an if statement in SPSS. I know we haven't covered all of this yet in SPSS, but I'm assuming that some of you have already had some experience. Whereas a single equal sign is an assignment equals. So if you want to assign something to an object, you're going to use a single equals. All right. R offers a lot of data structures, unlike SPSS. SPSS essentially offers one data structure, which is a table. So you have this big thing that looks like a spreadsheet in SPSS. In R, you have a lot of different ones. So let's start out with the most simple data structure, which would be a single element, you know, like a double precision real. So if I said x is equal to 5, I've just assigned a variable or an object x the value 5. Now, you can view all of your objects by doing ls. So let's do an ls, and you're going to see that in this directory there is now an object called x, which wasn't there beforehand. If I type x, you'll see it displays that object, and it has the value 5. Okay, so that is one object. Now, if we go back, we have a whole lot of other data structures. So C is used to specify a vector constant. So for example, if I said C is equal to, X is now equal to C, 1, 2, 3, 4, 5. Okay, X is now a vector, and if I type X, you'll see that it has the values 1, 2, 3, 4, and 5. Now, I can put any numbers I want in a vector constant like that. Notice these are sequential, so 1, 2, 3, 4, 5. An alternative way to do this would be to say x is 1 through 5. Okay, so 1:5 means a range, and you'll notice that I have exactly the same thing. If you go back to my course packet, I used 0, 5, so let's do that. X is equal to 0, 5, and now we get 0, 1, 2, 3, 4, 5. You might be curious about, well, how do I remove an object? You remove an object with rm. So if I say rmx, parentheses x, now you'll see that there are no objects in my folder anymore. Let's go back, and I'm going to assign x the constant 0 through 5. And in the course packet, I show you various ways of referencing elements of a vector. So for example, if I said x 2 through 4, what that means is I want you to print out the second, third, and fourth elements of this vector. So before I do that, let's just go look at this. This is the second element, the third element, and the fourth element. So when I hit enter, it should print out 1, 2, and 3, and sure enough it does. Likewise, if I said print out element 5, it's going to print out the fifth element. So if I look here, that's first, second, third, fourth, fifth. So 4 is going to be the fifth element in this array. I can put a minus sign in front, so if I want to drop, say, the first element of the array, this is going to print out everything but the first element, so it should return 1, 2, 3, 4, 5. And sure enough, it does. All right, so those are just some basics of manipulating a vector. There are a lot of other functions that you can apply to a vector. So I hinted at a mean. So if I take the mean of x, this returns the value 2.5. Well, where does that come from? It's really the sum of x. So the sum of x, if I add up all these elements, is 15. I'll do an up arrow. Divide by how many elements are in there? I think there are 6 elements. And so that's where that mean of 2.5 comes from. The length function also works. So the length of x is 6, meaning that there are 6 elements in this array. So I just brought up my previous command. Instead of typing 6, maybe it would have been a better idea to let x count the objects, and that would be another way to get the mean. I can get a standard deviation with SD. I can find the maximum value with the max function, and get the minimum value of x with the min function. So that's some of the stuff that you can do with a vector. I can get a histogram with the hist function. So my computer is off in deep thought here for a second while we're waiting for this. And so here we have a histogram of x. All right. I don't want to get too much into matrices, but you know, we can also make a matrix. In the course practice, I called it x. Let's make another one called y. So matrix specifies a matrix constant, and let's just type in these elements. All right, now you have to specify the dimensions of your matrix. So I said number of rows is 2. So what this is going to do is it's going to read this constant into a matrix. It's going to have 2 rows. So this will be, the first column will be 1, 2. Then we've hit the number of rows, which is 2. And then the second column will be 3 and 4. So let's display that. So sure enough, 1 and 2 go in the first column, 3 and 4 go in the second column. Now let's move on to some other tasks that you might have to do. So first off, manage giant data sets somewhere else. So R tries to have data sets in memory, and if you have a giant data set, R will crash. Right? So you want to have all of your data living in some relational database package or in SAS, and you want to do all your complicated pre-processing somewhere else, and then you're going to import a data set into R to estimate your models. You'll find R to be very good at estimating various models, not so good at the pre-processing, in my opinion. Okay, so a really common scenario would be you're provided with some data, or you're managing a big data set somewhere else, and you dump a data set into a file. So here's the employee data set from Siegel. You're going to notice that it's in a file called employee.csv, which is sitting off in ECM teach data. So it's in that location. Now, this happens to be a comma delimited file, so I can bring that comma delimited file in with read table. So read table is a very useful function. You probably want to read through the help page on it sometimes. So remember, to get help, you always type question mark. And this gives you all the options. So you can read through this at your leisure, whether or not there's a header in there, what the delimit character is, how to handle quotes. You know, these are kind of advanced options that we're not going to deal with right now. Then it gives some other functions that are similar to this. Read CSV, read CSV2, and so forth. Okay, so you can read through this on your own. I'm going to bring this data set in. So I'm going to make a new object called employee. So employee is going to take the value read.csv, and I don't have to give the whole path since I'm sitting in this folder, employee.csv. And if I hit enter, I now have a new object called employee. So you'll notice that in addition to X and Y, I now have another object in my folder called employee. Now, employee is a different data structure. It's called a data frame. Now, anytime you have a data frame, there are a lot of things that you can do to it. So one thing that you can do to it is find out what variables are in it. So if I typed employee, it would display the whole thing. Now, you usually never want to do this, especially if you have a large data set. So if you have 10,000 observations, you don't want to print everything to the screen. Employee only has about 70 some cases, so it's not going to do anything horrible if I hit enter. So this is what employee looks like. So you're going to see that there's about 6 variables, and you're going to have 71 cases, and you have all the data there. Now, let's just go through. If I want to just know what the names are, so let's say I had a giant data set that I didn't want to print the whole thing to the screen. Well, if I said names, employee, it's going to return those 6 names that are the variables. A few other functions. If I want to know how big is this data set, dim returns the size of it. So this means 71 rows, 6 columns. If I don't want both the rows and the columns, let's just say I want the number of rows. I can type n row employee, and col would give me the other one. A really useful function is summary. So summary gives me basic descriptive statistics on each variable. So if I have a numerical variable, it's going to give me the 5-number summary, so the minimum, maximum, the 3 quartiles, as well as the mean. If I have a categorical variable, it'll give me a frequency distribution. Now, if I want to reference a particular variable, for example, employee $female will give me all the values of this variable female. So you'll see that there's actually 71 values. If I want to count the values, why don't we go count these values? So you remember the length function. Oops. Length function gives me the length of a vector. So sure enough, this has 71 elements. Now, if I don't want all of the values, I could specify, just give me the first 10 by specifying a range. All right, I can also think of this thing as a matrix. So if I said employee, comma, I think employee was what the female was the 3rd variable, so just give me the 3rd column. That would be another way of getting only the female variable in here. So let's look at my little question. How could we print rows 4 through 8 in columns 2 through 3? Well, we would just say employee 4:8. So that means rows 4 through 8, columns 2 through 3. So now we know their salary and the gender for employees 4 through 8. I think I've covered everything on this, at least the first couple bullets. This search is a little bit more advanced. So let's take a look at what happens if we type search. You can kind of ignore this if you're not interested at this point. It's not essential. This search displays the search path. Okay, so what that means is whenever you type a command like mean, R is going to go looking in all of these places. Right? First, it's going to look in global environment, whatever that is. So that's going to be in the current directory. That's like where we saw X, Y, and employee. If it doesn't find it there, then it goes on to package stats, package graphics, and so forth. All right, now, instead of having to type employee all the time, I could attach. Let's attach employee. All right, now if I do a search, what you're going to see is that it's first going to look in my global directory, then it's going to look in the employee object, what happens to be in the global environment. So if I typed female right now, you're going to notice I get that vector. So where it found it was that employee place. All right. By the way, if you don't want to have something attached anymore, the way you unattach it is to detach it. All right. So now if I do a search, you'll see that employee is no longer there. So if I'm working with one data set, I may want to use this attach and detach option. All right, continuing our grand tour of R, you can do arithmetic in R. So R is, you can think of it as being a very fancy calculator. So plus does addition, minus does subtraction, and so forth. So I could do something like 4 minus 3, 4 minus 2, I guess, and it's returned as 2. Let's take a look at x. If I took x minus 1, what happens? Well, it's going to subtract 1 from every element in that vector, or x plus 5 adds 5 to everything in that vector. If I do star, I get multiplication, so x star 2 multiplies every component of that vector by 2. If I wanted to exponentiate this, I could do something like, x squared is going to square all the elements in that vector. So the caret sign does exponentiation, just like in Excel. If you want to do integer division and remainder, you use star slash star for integer division and star and percent for the mod function. For example, let's take x and we're going to do divided by 3. So notice we get numbers with a bunch of remainders. However, if I did x star slash star 3, I do integer division, and so you'll notice that 0, 1, and 2 divided by 3 rounds down to 0, while 1, 2, 3, 4, and 5 divided by 3 rounds to 1. If I want the remainders, I just do percent, and so now you get the remainders. R offers a ton of special functions. So square root, I'll take the square root of 25, there it is, the square root of x. I can apply those to all those. If I want the log of something, I get, I can do that. Now notice I can't take the log of 0. Question, how do we find base 10 logs? Well, I'll give you a hint. Ask for help. So if you do question log, you'll see that there's actually a log 10 function, or you can specify the base as an optional argument. So let's take the log of x, base equals 10. And so then that's how we would find the base 10 logarithm of numbers. I think I've already gone over these functions with you. Another really important feature of R is that sometimes you'll have categorical variables. So when you have a categorical variable in R, you have to treat them as factors. So, for example, in this employee data set, let's go look at a frequency distribution. So if I do table employee $train lev, you're going to get a frequency distribution. This happens to be a categorical variable. Now, currently, it's going to be treated as numeric just because there are numbers in there, but we usually don't want to do that. So we can make this a categorical variable by specifying it as a quote factor. We can also give value labels. So this is just like the value label column in SPSS. So I'm going to type this in directly. By the way, from my course packet, if you don't want to have to type everything, you can just highlight something, hit copy, and then you can paste it, and that'll save you from having to type everything. Now let's repeat the table command, and you'll note that we have low, medium, and high in there instead of 1, 2, and 3. If I do a summary on employee, remember I said that when you have a categorical variable, you get a frequency distribution. So now we have a frequency distribution of training level as opposed to what we had before. So if we scroll up, before we treated it as numeric, so we had the 5-number summary. Now we have the frequency distribution of training level. Now, factor assumes that the values are numbered consecutively, beginning with 1. So like 1, 2, and 3 is exactly what factor wants to see. What happens if you don't have something that's numbered consecutively and or beginning at 1? Well, we happen to have such a variable in this data set, which is female. So female takes the value 1 if the person is female and 0 otherwise. So we need an additional option for the factor statement, which is levels. So this level says, okay, I want my levels to be 0 through 1. That's what the 0:1 means. And then corresponding with this level 0 is going to be male. Corresponding with the level 1, the second one is going to be female. So, I'm going to be a little bit lazy here, and we'll just mouse this over, I hope. I hope it works. Usually works. Let's see if it will work. It might not be happy with me. I guess I'm going to have to type this because it won't let me just mouse that one bit over. So I guess it won't hurt to talk this through. So we're going to overwrite employee dollar female. So female is one of the components of this object as being a factor. Well, where do we get the data from for it? Well, employee dollar female. Better spell it right. The levels will be 0 and 1. So I used 0:1 just for variety's sake. I'm going to put specify a vector constant, so 0 and 1, like that. That's equivalent to what I had in the course packet, but I just want to show you a little bit of variety and refresh something we covered earlier. And then labels, just for fun, I think we're going to call this M and F for male and female. All right. Now, if I do a summary of employee, you'll note that I get a frequency distribution of female. Another special type of variable is a date variable. So the way that SPSS and R and other software packages store dates is that it'll be recorded as the amount of time that has elapsed since some starting point. So R chooses its start of time as January 1st, 1970. So it's going to store any date that you give it as, how many days have elapsed since this date. Now, the reason that we want to store it that way is because it makes it very easy to compute the time between two dates. We want to do this all the time when we're analyzing customer databases, because we want to know how recently has it been since a customer purchased. So that would just be today minus the date of the most recent or maximum purchase date, and then that would tell us whether this customer is lapsed or not. We also want to compute variables such as the time on file. How long has a customer been around since the first order? All right, so we need to compute a difference. Okay, so how do we cast or create a date variable? The answer is we want to use the asDate function. Now, you can pass a date string. So this is just a string right here, 1970-01-02. That's a string. You pass this to asDate. It returns whatever that date string is as a date variable. Okay, so it also prints it correctly. So this is going to be printed as follows. So it looks like nothing has happened, but something really has happened. It's been converted from a string into a numeric variable indicating how long it's been since this date. So just to see that, if I then print this as a numeric variable, so let's just walk through this next line. I've converted this string into a date variable. Now I want to print the date variable as a number. And so what you'll see is that the number is 1, indicating that on January 2nd, 1970, that's 1 day since January 1st, 1970. All right, so I want to talk about a couple things on this slide. So number one is, how do we read in dates of other formats? So, not all date variables will come to you as the year dash or slash month dash or slash the day. Sometimes you get a date variable that's formatted like this. So what you need to do is then specify a specific format, a different format than the default being year slash day, month slash day. So we use these symbols. %D is going to be a date. %B is going to be a month spelled out. %Y is going to big Y is going to indicate a 4-digit year. So this would read in exactly the same thing. Here's an alternate format where it's month, month, day, day, year, 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 year. So I'm going to use %m to indicate to R that it should first find the month, then the day, then the year is 4 digits. If you're from Europe, you represent dates as day, day, month, month, year, year. So here's the format. All right, so that's how we can bring in different formats. By the way, if you only have a 2-digit year, you have to use a little y rather than a big Y to read it incorrectly. Now, once you have a date variable, there's a lot of stuff that you can do to it. For example, if you want to know what day of the week is January 2nd, 1970, then you use the weekday function. If you want to find out what month that is, use the month function. So here month says, okay, it's January. And I didn't do weekday here, but if I wanted to, I could. So let's try that. Weekdays as date, better make that capitalized, 1970-01-02. So it looks like January 2nd, 1970 was a Friday. All right, if you want to find out the time that's elapsed between 2 days, so for example, what is the distance between January 10th, 1970 and January 2nd? All you do is you use a subtraction operator. So it tells us 8 days had elapsed between those two. You can also do comparisons. So is this date after, so after is greater than this date, and you'll see, yeah, it's true. Is this date before that? No, and it's false. So real quickly, let's go over and look at the defaulting customer data set. I ran a summary on this, and what you'll see is that enroll date has exactly the format we want, but it's been read in as a factor. So if you type class that, you'll see it's a factor. So if I want to make this into a date variable, all I would do is, let's make an additional object off of the default list. So let's say default $enroll, we'll just call it enroll, is going to be as.date default $enroll date. Now notice that the dates take exactly the format we need, so go hit enter, and it looks like we've done it. So let's do a summary on default. Gotta spell it right. And so what you'll see is that this original thing is still a factor, and it's giving us a frequency distribution, whereas enroll is now going to be treated as a numeric variable, and it's going to tell us the minimum enrollment date was January 1st, 2007. The latest enrollment date was March 31st, and all the other statistics that go with that variable. We could then find recency if we wanted of this. The way we would do that would be something like, if today is April 1st, 2009. We want to see how long a customer has been around. Say default $TOF is equal to as.date, and now we need to specify this 2009/04/01 minus default $enroll. And so now let's do another summary. And we get the information about this. So let's go look at default $time on file 1 through 10, and so you get here are the different differences. That's how long customers have been around. That first customer has been around 701 days, and so forth. So that's how we deal with dates. I'm not going to talk about merges in this video, but if you want to do any sort of merges, for those of you who've done SQL before, there is a merge command in R, and I think this slide illustrates the different merges pretty clearly. At this point, it's your turn, so you should read in the membership case. So you're going to use read CSV. There's a couple categorical variables, so payment type's a little bit tricky because notice it's not numbered consecutively. It's 1, 3, 4, 5. Gender and age. Actually, it looks like I gave you some of these statements, but I want you to read in this data set and be prepared to analyze it. Okay,